Hello, everybody. How's it going? Thank you all for taking the time to join us today, uh, talk about various functions and features related to Global Mapper as well as Geographic Calculator. So I'm going to go ahead and share my screen here and talk about a specific use case here. And that use case is going to be performing a suitability analysis for a solar farm using Global Mapper as well as some Global Mapper Pro tools. My name is Gus Cooke. I am a senior application specialist here at Blue Marble Geographics. Hello to everybody that I've had the opportunity to work with all throughout the world. I work on the technical support team here at Blue Marble. So if you've reached out to GeoHelp, which is our technical support inbox, chances are we may have interacted at some point. So this is going to be a two-step process, and what we're going to be doing is utilizing some publicly available data in order to perform this suitability analysis. That publicly available data is going to be some USGS 3DEP digital terrain model, some elevation grid data, as well as a publicly available parcel map and some 3DEP lidar data that we're going to also utilize to create a digital surface model. I'll talk about the difference between those when we get into it. So again, yes, we're using this publicly sourced data, and what we're going to do is use this data to identify the parcels that meet a specific set of site requirements. Now, these site requirements include at least the parcel size being 10 or more acres. Each of these parcels should be within 0.2 miles of a power line. Um, they should optimally be south facing because we're performing this analysis in the northern hemisphere. South facing slopes are generally get a little bit more sun. And then we want to ensure, on average, a maximum slope of about 5 degrees here. I'm going to go ahead and shut my camera off so we can focus in on our slides here. So this is going to, again, be a two-step process. The first step is going to be locating our potentially suitable locations. Once we've performed that process, this is going to involve connecting to a web map service through our Connect to Online Sources tool, downloading data to store it locally so we can use it in our analysis, then using the Vectorize Raster tool to take that elevation data and create polygons or area features that represent specific areas of particular slope ranges or slope direction ranges, which I'll talk about as we get into it. Moving on, this is gonna be very vector heavy for this part of the analysis. We're going to use the spatial operations tool. Essentially, spatial operations and spatial operations predicates allow you to identify features within one particular layer based on their kind of relationship to features within a second layer. Then we're going to perform a data query to kind of, based on the results of that spatial operation, further narrow down our set of viable parcels. And then lastly, we're going to apply a buffer to our line features representing the locations of our power lines, and then do one more spatial operation to find all of the parcels that are within that 0.2 mile buffer. Once we've gone through all of that, then we're going to move on to a second part of the process, evaluating our candidate locations. And this is going to utilize what I was really excited to talk about today, a new feature that was included within Global Mapper Pro version 26.0, our solar shadow calculations tool. So using some USGS 3DEP LiDAR data, I'm going to generate digital surface models. So a digital surface model, for those of you who might need a refresher or may not be familiar, is going to contain my built structures as well as my vegetation. I want that to be included in my solar analysis. So that's the reason that we're not using the 3DEP elevation grid. That's why we're going to create these new grids that are going to include my trees, include my buildings. So those will affect my analysis. Then we're going to use that as the source data to perform this solar shadow calculation, which is going to create a new raster surface in which the per cell values represent the percent in shade versus in sun. We're going to combine some of those outputs to get kind of a yearly average using our raster calculator tool. And then we're going to actually apply those percent in shade values to my parcel features that I've identified in order to create kind of a nice visualization colored based on that attribute representing my kind of optimal candidate location. So let's jump into the user interface here and talk about how this process works. So initially, I'm going to talk about kind of source data acquisition. Global Mapper allows the connection to a set of built-in online data sources. So that can be a web map service, web map tile service, or anything else that you want to connect to. You can always use one of the built-in sources, or you can add your own source if you have a particular streamed data source that you want to connect to. Once I've connected to that, you can see, for example, I've connected to the 3DP elevation grid here. I'm going to just enable. It's being streamed in, but in order to use it for our processing, we want to store it locally. In order to do so, we would just select that layer for export, and then export that to a locally stored file, depending on whatever kind of file format we want to choose. So what I've done, I've already done this process here. I've stored it locally. It's ready to go for use in my analysis. So let's start with identifying out of another one of my source data layers, my parcel layer, which of these parcels is likely going to be the most suitable based on our set of criteria for a solar farm installation. So the first thing that I want to do is extract areas of specific slope ranges from my elevation data. And I'm going to do this utilizing our Vectorize Raster tool. So I'm going to go up here. It's kind of located here, and we call this the Advanced Digitizer toolbar. You can see a little pencil drawing a little line there. And I would just select that. But prior to doing so, I'm going to actually switch to our slope shader. So now, because I've switched to our slope shader, when I open up this tool and making sure I'm choosing the correct layer there, it's going to allow me to, rather than extracting a particular range of elevations, if I had a regular elevation shader enabled, it's going to allow me to extract a specific range of slope values. So our target range here is 0 to 5 degrees. And after I ran that, you can see that that's a pretty wide coverage in terms of 0 to 5 degrees. This is there isn't a lot of kind of range and slope in this area. So we're pretty good to go in that aspect there. Moving on, we're going to talk about identifying areas that are within our required slope direction or our orientation of the slope. So we're going to switch from our slope shader to our slope direction shader. And we can see that these degrees no longer represent slope, they represent the orientation of the slope. So we want south facing. South facing is going to be about 250 to 150 degrees. We're going to go back with this slope direction shader enabled, go back into Vectorize Raster. And then we would enter the range of values that we want. So let's say 150 to 250. And I'm going to discard all areas that are smaller than, say, 100 acres here to just get more generalized locations. So we can take a quick look at the output from that. We have a couple of these vector features representing our south-facing slopes. So the first thing I want to do is perform a spatial operations on my parcels and my south-facing slopes, or my larger regions of south-facing slope. And I want to identify all the parcels that intersect with these particular features. So I'm going to open up our spatial operations tool here. And then within spatial operations, I'm going to choose my source or my source data, and then kind of the layer to compare against. So we're going to be identifying all of the parcels that intersect with our south facing areas there. And then for my output, I'm going to create a new layer. And I've already run this for us. So here's our output. I'm going to toggle off my parcels, toggle on just my south facing parcels. And we can see that there's a lot of small ones here that don't meet our 10-acre minimum size criteria. So in order to deal with that, I'm going to query this parcel layer based on a particular attribute, which is the acres attribute. So I'm going to select this search vector data tool. And what this is going to allow me to do is enter a custom query in order to limit this result. Right now we're viewing all of the features within that layer. So what I wanted to do, I didn't mean to close that, with apologies, let me reopen that very quickly, is enter a very simple formula here. So I'm going to add my acres attribute, and we want greater or the same than 10 acres. I'm going to search, and we're going to narrow that list down to just the features that meet that particular criteria. So with those selected, what I did was just Control C and then Control V, and I copied those to a new layer. And we can take a look at that layer that I was able to generate here. And that new layer is our south facing 10 plus acres parcels that we've been able to identify. Now for one more kind of vector analysis part of the process, we want to make sure that the parcels we've identified are within a 0.2 mile boundary from our power line layer. So we have our power lines here. They're kind of hard to see, so I'm going to just temporarily turn off all my kind of base map there. So the first step in this process is going to be to select all the features within that power line layer and then create a buffer feature. And that buffer feature is going to be a 0.2 mile buffer. And we can take a quick look at that buffer that we were generating. And then the next step in that process, I'm not going to show it here because we've already talked about spatial operations, is to go back into spatial operations. I'm going to run another intersect on my parcels, my identified 10 plus acre south facing parcels, and my 0.2 mile boundary around my power lines. So this is going to result in this layer here. These are my identified parcels that meet that specific criteria. And you may note that they have some styling applied to them. And we're going to talk about how we got to have that styling applied. So we're moving on from the first kind of step in the process, which is going to be locating potential sites. Now we're going to evaluate our potential candidate sites. So the first step in this kind of second process here to evaluate these that I performed was obtaining some 3D EP source lidar data. So the data that's used to generate this digital elevation model. But we want to obtain that source data in order to create a grid that, again, includes my vegetation and includes my built structures so I can use them in my solar analysis. And I did this on a more localized level. I'm going to switch to just a regular elevation shader there. And those are my two kind of source grids for each of my sites. So what I did was download some lidar data from the 3DEP online portal, and then I loaded it in and then used our create elevation grid tool to create these DSMs that I'm going to use. So these are going to be the source data for performing our solar shadow calculations. The solar shadow calculations tool can be found here in the analysis toolbar. So I'm going to just select that tool here. and we can choose which particular layers we're going to run this analysis on. One thing to note, if we have 3D vector data, so any kind of vector data that has elevation values associated with it, we can actually utilize those as obstructions going to affect the output of our sun shade analysis. Now, for a specific, we can do this at a specific time or at a specific range of times and dates. So I'm going to specify my UTC offset. So we're in the northeastern United States for this particular area. So I'm going to do -4 for my UTC offset. And then for my start and stop time and date, I'm going to do the winter solstice first from 2024. So 12/24/2024 at 6 a.m. And we'll go to about 9 o'clock, 9:30 at night, sampling every 5 minutes. We're going to do this at a height of about 5 feet. That's kind of just an estimated height for a solar panel, hypothetically. And our output is going to be a shadow percent grid, where the grid cells represent the percent, or the values of the grid cells rather, represent the percentage of time that that particular cell is in shade. So lower values are going to mean more sun. So we can take a quick look at some of those outputs here, and this is just for example, for December. And what I'm going to actually do is go back and run this again, or let me enable my source layer again. Go back, run this again for a different range of dates. And this time I'm going to do the summer solstice, so June 20th. So I would enter that different range of dates, repeat that process, and now we have these two kind of layers representing the both kind of ends of the spectrum in terms of the amount of light per year. We can see that the June one get a lot more light than the December one for obvious reasons. So we want to combine those into an average. So we're going to do this using our raster calculator tool. We could choose our input layers here, and raster calculator allows us to kind of perform calculations on different input bands, and we can either subtract or multiply the per cell values of those bands to create a new raster output. And essentially what I've done is create two averaged shadow percentage grid files here. Now for a final step in the process, I actually selected my parcel layers or my parcels features here, and I want to visualize these based on kind of the shadow percentage or percent time that it's in shade. So we're going to use a little bit of a workaround here because these shadow percent cell values are represented as elevation. I'm going to just right click analysis measurement and then calculate elevation and slope statistics for that particular feature. Now that feature has a new set of attributes, one of them being an average elevation. So what I did was just change the name of that particular attribute and then colored that particular layer within my vector options, and then colored it as well as labeled it based on that shadow percentage attribute. And so my final output here are those identified vector features representing the parcels that meet our criteria, and they're styled and colored based on um, the lighter ones being less shade and therefore more suitable for a solar farm installation.
Hi, Gus. Thank you so much for that presentation.
Absolutely.
All right, so we've got some questions coming in from our attendees. I'm going to get started with that. The first one comes from Peter and is asking the use of the built-in map sources. Are those maps free for commercial use?
That's a great question. So each of our So we are not a data provider. So what we allow access to third-party web map services and other stream data sources. So the terms and conditions, you can right-click on a particular source and allows you to view the particular terms and conditions for that particular source. In this particular demonstration, I was using that USGS 3DP data, which is pretty much open for most, if not all, use cases, but it'll depend on which source you're connecting to.
Awesome. Thank you so much. So we also have another question from someone wondering how to set up the shadow calculations, how to get there and whatnot.
Absolutely. So the solar shadow calculations tool is a Global Mapper Pro feature, it should be noted. So you need to have a Pro license, and it is accessible either from the terrain analysis drop-down menu within, it was added in version 26, so you want to make sure you're at least using that version in order to be able to access it. It's going to be in the terrain analysis drop-down menu, and it's also in the analysis toolbar.
Amazing. Thank you. So another question that we have, it's a bit of a random question, but it does relate. We have someone wondering if you've attempted to script this workflow before.
Yeah, that's a great question. And I'm really glad you brought that up because you may have noted that part of that workflow was kind of this repetitive process where I needed to kind of repeat the same tool with different parameters. So I was just changing the date and time range and then running it basically 4 times, twice for each site. And there is a global mapper script command for the solar shadow analysis tool. So that is definitely something that would benefit from being automated using Global Mapper script language, especially for that part of the process. But yeah, generally all of this could be potentially scripted for sure.
Awesome. Thank you so much. We've got someone wondering if there's any training available for custom raster calculation formulas.
That's a great question. So I know that we definitely talk about the raster calculator tool, and specifically with the NDVI analysis is kind of the example within our public classes. I don't think we currently have anything in terms of custom training related to that particular tool, but definitely, the way that I would go about it is reach out to GeoHelp at bluemarblegeo.com, which is our support team, and we will be happy to help you. Whatever your specific use case for that tool might be, will help you get kind of up and going with that as needed.
And then finally, I'm going to ask, why do the shadow percent grids show meters as the unit of measure in the scale bar? And also as a second part, can we use vector data like 3D building polygons as obstructions when performing solar analysis?
Awesome. Yeah. So two good questions there. The first of which, so you can. It's good to note that although in Global Mapper it's going to treat any kind of it can treat any kind of non-RGB raster. So it's any raster which is just a set of cells, and each of those have a particular value that represents them. It doesn't need to specifically be elevation, but you can load it in, and Global Mapper will treat it like elevation, which allows you to kind of perform different kind of quote unquote elevation specific kind of workflows on that raster data, regardless of what those kind of Z values per cell values represent. And then in terms of the second question, yes, you can use 3D vector features as obstructions within the solar analysis tool.
Well, thank you so much for your presentation, Gus. I'm going to welcome Jess back.
Awesome. Thanks, Meg.